so confusing.
To answer your question, will there be a help session for each of these? I'm planning on just doing this kind of the day that each homework assignment is due. That way you guys can answer, get any questions answered that you need to. But like I say, if you're struggling at 10 or 11 o'clock at night, Brian, just take a picture of it and email it, or Google Hangout, Google message it to me, and I can comment on it. You know, if it takes you an extra day, it takes you an extra day. That's just, we're going to all have to be flexible on that. So even if you log in right now, I am recording this thing so I can turn it into a YouTube video and post it for anybody who isn't able to log on here. Just a couple things, and you three really aren't the ones, the three that are looking at me right now live didn't really have any of these issues. But number one, I did get all of the homework graded, and you have grades for it for the concave mirrors in Canvas. There's comments listed on everybody's. I'm still learning how to make marks on there where there were mistakes. I haven't quite figured out a good way to do that, but I'm working on it. Number one advice would be just copying what the answer key has for the work isn't really showing your work. I understand that you might need to help you get started or to start over if you're on the right track, but just copying down what is in the answer key is not what you should be doing. Try it yourself and then check your answer to see if you're right. If you're wrong, use the key to help guide you in the right. Second thing would be, most of you did this, but some of you were not labeling P, Q, F, and C. So please do that on your ray diagrams. What I grade is the order of P, F, and C.
Is that all we need to label on our ray diagram? Just P, F, and
yes.
Okay, good. Because I was thinking about
yes, P, F, Q, and C. There's a lot of other things you could label, but that's not what we need to label. Having the order of those four things is important because that tells me that you've set the problem up right. I mean, you're going to look different than somebody else's, but if those things are in the right order, it works. Next, the need to make an image. Now, that's easy for some ray diagrams and hard for others. Some people just kind of gave up on that. So make sure that they make an image. The problem was some people just kind of saw the rays and then they reached the edge of the page and then they stopped. Probably if you had an extra foot of paper, you could have made these. So you can tape a piece of paper to the end or redraw it in a different scale so that works. But again, overall, I was impressed with people. You guys are really doing a good job overall. Don't forget to ask questions. As I told Brian, email, send a message, take a picture of number 6 if you're working on it, whatever. Hey, where am I stuck? Where am I going wrong? We can have those conversations, maybe not live like this, but I monitor my messages quite a bit.
One more question. Do we always need to find M? Like for each problem, do you want us finding M or just like whatever it asks?
No, you don't have to find it if it doesn't ask you to.
Gotcha.
You only need to find what it asks you. Sometimes people like finding it to see if your ray diagram makes sense, because if you get an M of 14, then your image should be bigger than your point something, and your image should be smaller. So sometimes it helps you know if you're on the right track. Along those lines, if those of you who are watching this, but I'm recording this, so make corrections if you screwed something up, if you forgot to take screenshots of the simulations. If I took a point off on all your ray diagrams for the same thing, resubmit it, make corrections. That's how we're going to have to learn. We're not all going to be good at this at first. So if there's anything wrong the first time, I put it in the comment section. Can earn some points back. Lastly, I put this in the convex mirror assignment. I want you to try to submit all of your pictures as one big Google Doc or one big PDF. You can't figure it out right away, that's okay. But it's actually a lot easier for me to grade. Plus, later on, when you're trying to find this stuff, you know they're all in one file. All you have to do is search your Google Drive for convex mirror problems, and they'll all be right there in one file, instead of like 17 different pictures that all have these crazy file names. So I think that's going to work out better. Again, if you already submitted or you have to do one more assignment, submitting 17 images individually, that's fine. But I think I'd like to transition over to that.
Do you
turn it over to you guys?
Do you remember if
Other
mine was one
questions?
big file, or did it get sent individually?
Good question. I can tell you that shortly as I look over here on the grade book.
Because I've been having to submit like pictures from my phone, and I'm always scared that it's like not gonna go through.
So this is running really slowly right now because I'm recording it, so it's taking forever. Go ahead and check all. If you got your grade, it's all good. So
okay.
Let's just leave it at that.
It
I'll put this little message in the chat bar too. Yes, these are going to be all in Canvas, and yes, later today I'm going to upload to me, but they are all in Canvas right now. What other questions do you have? I have one problem I want to go over. If you don't have any questions on the homework, even on the convex mirrors, general questions, you can type them or you can talk. There's only it's only 5 of us, so I think we can probably talk to each other.
Number 2 on the convex.
You said number 2, Brian?
Yeah, I tried doing it, but I'm failing.
All right. Let me ask you this. What did you plug in for F?
60 meters.
Okay, and that is wrong. What sign should every F and C have in this assignment?
Negative, right?
Yes. Does that help?
Negative. I'll see if it changes anything.
Probably most of the time, the wrong answers can be traced back to a wrong sign on these problems. People forget to plug in a negative C or negative F for convex mirrors. Good question. I put that in the comments section as well. All of these on the convex should be a negative F and a negative C to plug in. Or if you're asked to solve for it, like one of them on here, like number 6 and number 8, you had to solve for F and C. It should come out as a negative number. If you plug in everything else right, you should get a negative on those.
Can we go over number 3? I was having trouble finding one of the given. Can't remember which one it was.
Change anything.
Yeah, I think Emma's asking about number 3. So that's a little bit of a weird one. They're pretending that, well, they're not pretending, but there's a moon with a diameter, and we're going to make a big mirror out of it. So one of the tricky things about that one is they give us the diameter of the mirror. We have to cut the diameter in half to get C, the radius. And then we have to cut that in half again to get F. So that might be where you went wrong.
Yeah, I think so.
And you said
so I'll add that in the comments section.
For diagrams, you have to have everything labeled?
Yes, PQFC needs to be labeled, and then you need to draw the object. I think that was kind of self-explanatory.
Okay. Wait, you said PQF. Oh, never mind.
And C. Good questions. I'm going to switch over. You can keep typing or talking to me to ask questions. I'm going to switch over to the drawing board here.
Should we even be worrying about like the stuff on the answer key, like the 2R stuff? Because I don't.
Ask me that again, Brian. What are you worried about?
What's with the 2R stuff on the answer key? 2/R. I just kept seeing that in the last one. And
So I think Brian's asking about says 2/R.
And I know we know of the 1/P plus 1/Q equals 1/F, but I don't know where we ever talked about 2/R. And I don't know if that's
Well, Brian, that's
needed
just
in our
if you
equations or
substitute.
not.
Yeah, Brian, just substitute instead of 1/R, put, I'm sorry, let me start over. One over F is equal to 2/R because R and C are the same thing. So I'll put that in the comments as well. The answer key called CR. So Brian, that's just a consequence of the fact that if you take F times 2, you get C.
But would we be fine if we just did 1/F?
Yes.
Because I'm using.
You can find F and then double it to get C, which the book calls R. Good question.
Double it?
Looks like we have a few more people joining here. Hey, everybody. Ahmed's on.
Mr. Kenning, do we have any homework assignments? Or is this just like going over notes?
Yeah, so the convex assignment is the new one. I mean, it's not new. It's been posted for a while. So concave was due. Yeah. Concave was due Wednesday, I believe, and then convex is due tonight at midnight.
That could me that.
I don't see it in the home.
You guys got to go into modules. Sometimes they don't. Sometimes those announcements are a little funny.
Okay, because I didn't see that. I just looked at the home and I didn't scroll down, so I didn't know we had home. Okay.
I didn't see the.
Yeah, I think you were one that didn't submit it. So yeah, just submit it when you get a chance. But if you go in modules, that's the best place to look. That way you know where we're at and can keep track of the things that we're doing for that week or that day. For everybody else here, if you're watching, and even if you're not, I'm recording right now. I just want to, you can see, can you guys all see my notes there?
Yeah.
Yes.
Yeah.
Can you guys all see ray diagrams?
Yep.
All right, I'm going to show you number 5 here because number 5 was a bit confusing. And then if you have any other questions, you can ask in the chat window on the side. Or you can ask me. Number 5 was a little bit confusing because it talks about a scale model. So what they want to do is look at a full-size steam engine and have it look just as small as it would be in the scale model. So what scale at 1400 to 1? It's actually the magnification. And the scale model is smaller than the original. So we're actually wanting the magnification to be 1 divided by 1400. So that's what I'm showing you on the screen right now. You have to take 1 over 1400 with 2 sig figs, and you get this decimal that I'm pointing to here. So that's kind of the key. And then it's key. The other key is to just recognize that, right here, F is negative in all these problems, as we already talked about. So that's kind of what I'm going to try to circle in. I meant to use red, but whatever. Make sure that all these F's and C's are negative here. And then again, here's the ray diagram. I'll just highlight how these work. Every single ray diagram on convex mirrors has a virtual image. Let me say that again. Every single ray diagram on these will end up having a virtual image. So where are they going to be? They're always going to be over here. They're always going to be behind the mirror. This is where Q will always be. And let me just refresh your memory on how that works. Here we have parallel. It bounces off the mirror. It diverges, so parallel and through F. Then we have this ray, which is lined up as if it's going through F and then parallel. We have the third ray, which is lined up as if it's going through C, but it bounces back where it came from. Finally, how do we figure out where the virtual image is? We have to trace the 3 reflected rays back to see where, not where they actually meet, but where your eye looks like, where to your eye it looks like they meet. So that's what the green is representing here. I'm just taking the 3 reflected rays and tracing them back. And hopefully then you can see, if my computer isn't lagging too much, that they all come back together right here. And this would be where Q shows up. This is where your image, so Q is virtual. Any questions about what I just said? Virtual image, as I can scribble it on here.
Looking at the calendar, I saw the practice quiz. How's that going? Oh yeah. So when you try and find M for magnification, do you use either H prime over H or negative Q over P, depending on which givens you have?
That's exactly right, Brian. You can use either one depending on which givens you have or whichever one's easiest. Sometimes you can use both in the same problem. Yes. I'm going to stop sharing my screen and go back to the camera. I don't know about you, my eyes and my right hand and arm is sore from all this clicking and staring at a laptop for hours on it. I need a spring break just to get outside and do something.
Yeah, probably won't happen for anybody if they initiate martial law.
I recommend you get blue. I recommend you get the blue light glasses, the blue filter glasses. That's what I'm wearing right now. Yeah, that helps. Because
oh, really? Okay.
That's when I'm on the computer, when I'm doing homework. That's why I wear these.
I gotcha. Twin down. Twin down.
3. Other source of there forming surrounding largest thing.
I'm probably going to stop the recording here because it looks like I've covered all the main points. You guys are welcome to stay on here. I'll stay on here as long as you guys want. If you have any further, work one out while I'm here. You can call me on Google Hangouts and we can like talk that way. Or on that thing, if you're working through problems or ray diagrams and want me to, hey, does this ray diagram look good? Grade this for me. I could easily do that. You're on the right track. So that's an option.
On number 3, they're talking about the diameter. Would I have to divide the diameter by 2 to get R, which is the circumference? And then divide that by 2 again to get F? Oh, did you talk about that?
That's exactly right, Brian. We did talk about it already, but you're exactly right. 70 divided by 2 would give you C, and then divide that by 2 again to get F.